back for one more video just to explain a couple more things. So you can see this is the streak effect, and what I've got here is two 32 LED strips on the sides and one in the center. And you can see the way the code works. The one in the center is 16 pixels, and you can see the way that it works is that it doesn't care that it doesn't have the other 32 or the other 16, even though that the Arduino is telling it to send signal to the other 16. So you can kind of use that effect. I tried making the code to use two different lengths of LEDs, but it was just way too hard. So it just controls one length of LEDs, and then you can cut them to however you want. They don't have to be powers of two. I just happen to have 32s and 16s. But some effects look good, but you'll see that this one, so this is a Cylon going back and forth, you'll see that shorter string in the center, it's not really doing anything while the others are flashing. So that one's not great for it to be a smaller cut, but one like this is a little bit better because that smaller string's always doing something, right? So anyway, I'm just going to talk about a couple more things. I made some notes because when I was doing the other videos, it was kind of hard to focus and talk about everything I want to talk about. So these are, I'm just going to unplug this. Hopefully you can see this. Perfect. So I mentioned that everything operated off of patterns and styles. So these are all the patterns that I've basically taken out of the fast LED samples, and I had for each pattern I had the ability to change the style. So that's why I was talking about, styles and patterns. So out of all of this, there's 43 displays, and I was just going to talk a little bit about the code and how it works, and if you want to go in and modify it. So there's about four things you'll need to do, possibly a fifth thing. So one is you have to go into the code, set the pattern button. That's just the pin on the Arduino that controls the button input for the pattern, and also the style button, the LED signal, and the number of LEDs you have to set. And just remember, it's a physical number of pixels. So this is a 16 and this is a 32. So when they talk about these WS2812B strips, they talk about each one of these in terms of pixels. So even though it's a 32 pixels, a 32 pixel string is always indexed from 0 to n-1. Okay, so you might have to set, there's one function in here, again, look at the fast LED samples, there's a function called add LEDs. Depending on the physical hardware of the LED strips that you might have to change that to something different. That's why I said get the fast LED samples working first before you try this. If you want to go in and add another pattern, the code is very structured, very modularly. I'll show it in the next page or so. If you want to add another pattern, just add another function, add another switch case in the loop function to call it. And if you want to add another style, just go make changes in each function directly and add a switch case in that function to select it. If you want to go in there and change the code, there's lots of opportunity to do that. Again, I would say do it in the fast LED samples rather than the code that I provided. You can change the delay statements. There's another function called beats in 16 or beat sign 16, whichever way you call it. But that will that will change the way the effect of some of the lighting works. Don't change any of the button code for the delays. The buttons on Arduinos are always very sensitive, and what's there is working. Don't change any of those delay statements. And if you do start modifying the code, again, I said the Arduino, the lights are indexed from 0 to n-1. If you go outside of that at all, like if you try to hit -1 as an index or n as an index, the Arduino might reset. So if you're doing some messing around with the code and you're finding the Arduino resets, that could be why. Again, just try it in the fast LED samples first. So this is a structure of the code. If you're not familiar with Arduino, basically every Arduino sketch has a setup function. So basically, as soon as it gets power, it does all the setup. And then once this is done, it starts going to a loop statement. And the loop just basically goes until the power's been turned off, right? So what happens in here, there's a couple of variables, I think they're called pattern and style. And so code starts, setup runs, goes into the loop. It says, okay, based on the pattern I have, go to the particular function and then keep running in there until the button is pressed. So when the button is pressed, each function while it's running asks, every time it does an update, it says, okay, I'm going to do my update. Now I'm going to go check if the button is pressed. If the button is pressed, I think it returns true, but also in here it increments the values for the current pattern and style. And if this thing comes back and says, yes, the pattern or the button was pressed, it doesn't care what happened, it just throws it back to this guy. So based on the current set of pattern and style, it throws it to the function. So if the function gets called for whichever one it is, it'll go and internally check, okay, based on the current style, this is what I have to do. So if you look at the code, that's kind of how it works. And if you want to add a function or style, just go there and do it. Okay, talking a little bit about the Arduinos, if you're not sure about any of this. So there's Arduino Mega, which is one of these guys. So you'll see it's got a lot of pins, it's larger. This isn't exactly correct, but in terms of computer talk, the Arduino Mega has 256 kilobytes of storage, you can call it storage, and 8 kilobytes of RAM. And these are all the pins that it has to interact with sensors and displays and stuff. So the Arduino Uno, it's a little bit smaller than the Mega. It's got about 32 kilobytes of what you can call storage and 2 kilobytes of RAM. And what's kind of nice is about the Arduino Nano, it's basically the same specs but a much smaller size, right? So what a lot of the times I do, I'll prototype something on this, take exactly the same code and deploy it to that. So if you just want to get started with this stuff, try an Uno, try a Nano. The code that I provided in GitHub, it uses, on the Nano, it uses about 28% of the storage available and 13% of the RAM on the Nano. And it's very similar to the Uno. I have the same code flashed on this one as I have on this one. So what I meant to say is that you still got, if you want to add more stuff onto it, you can add more sensors, whatever you want to do. There's still plenty of space for more stuff on the Nano. Okay, so the Nano voltage, here's the weird part. This particular one, I also meant to say that these are authentic Arduinos. So this is the authentic Mega and the authentic Uno. Arduinos are open source hardware, so the design is out there, and these aren't really clones, it's just they're not Arduino brand, but you know, they work, they're cheap, it doesn't really matter. I got this one from Banggood, I think. The recommended voltage on this guy is between 7 and 12 volts. You can see on the paper here, 7 and 12 volts, and it says the limits are 6 volts to 20 volts. But what I found is that it seems okay at 5 volts, and I know it even runs off the computer, and I think you only get 4 volts or something like that off the computer USB. So that's something to watch for. You know, it says that it's supposed to be higher, but I've found that it's okay at 5 volts. And what's nice, it's because the WS2812Bs also require 5 volts. So just watch for that. Okay, so a little bit more about the LED strips. Okay, as I mentioned before, every light is considered to be a pixel, and internally it's got an RGB LED in it. So at full brightness, the red, and I'm pretty sure these are right, but red will burn 20 milliamps, green 20 milliamps, and the blue is also 20 milliamps. So it will burn, every pixel will burn 60 milliamps at full bright white. So for example, a 32 pixel string at 60 milliamps each will about be 2 amps, which is actually quite high depending on, you know, what power source you have. You need to use a 5-volt battery eliminator circuit. They're fairly available. So what those do, you can you know, get a 12 volt voltage or some other voltage and drop it down to 5 volts. Use a multimeter to test the number of amp draw that you're using for whatever you set up. In just some of my testing, the Rainbow Fire was the highest at 400 milliamps on the 32 pixels. So that's what I'm saying. Like, these are only at full bright white, but the patterns are never really full bright white anyway. They're always a variation of a color, but you have to just be cognizant of that. Okay, so when you're going shopping for these LED strips, you want WS2812B. Those are very popular. They come in sizes, the 30 pixels per meter, 60 pixels per meter, which is what I have here. It's a good density. Or there's 144 pixels per meter, and those are packed really tight. I like the 60s. I usually get them in 60. You can get them in black or white for whatever you want, so just the strip is in either black or the white. When you're ordering them, there's some waterproof options, and these are non-waterproof. They're just, you know, the circuits are exposed, everything's like that. Sometimes couple different options for waterproof, and I mean, I have these ones. They come in a silicone sheath. I don't know if they're really, the silicone sheath isn't very, you know, it's good, but on the inside they're just still the same non-waterproof ones. Depends what you want. These are pretty bulky, take up a lot of space. I have another strip here. It's not the WS2812s, but it's a different type of strip, and you can see there's kind of a silicone dome on top of them. These are good too, but it takes up you know, a little bit more space, and that's what you'd have to look for when you're buying them. Some of the backing, you have to look at them. So say these ones I got from 2 different vendors, and you'll see this one, it's just there's no backing on the back. This one, if you can see it on the camera, it's got kind of like a blue peel off stick, so it's a sticky side. So depending what you get, just be prepared for that. What else? Oh, the grounding, if there's no backing, you don't want these contacting metal, because I imagine these will short out, right? So you got to make sure they're on something non-conductive, or put something on the back. For attaching them, as I said, I like these ones because there's no coating or extra bulk on them. I just put them down, and then whatever you're putting on them, just use some tape. This is good tape also. Just put some tape over top so they don't get dust or water in them. The other thing I was going to mention is that when you buy these things, every roll that I've ever gotten, they come with these, if you can see on the camera, they come with these wires already pre-attached, and so there's a positive, I think the negative is white, and then the signal is green, whatever. But then they also come with an extra positive and negative. And the reason that they do that is because when people are running these strips really long, they recommend that you inject more voltage here, because sometimes like these strings will be about 5 meters long, sometimes there's not enough amps to get all the way to the end of the string. But in any case, take these off, because these, I mean, there's a whole bunch of wires soldered, so take them off, solder your own wires back on, because these are not very good connections and very good wires at all. What else did I want to say? Okay, so coming back to the perf board and proto board, I just want to show you two different types. So this is something that I had from before. This is something called a perforated board. So you'll see that on the top there's no solder connections, but on the back there's solder connections, right? So this is one type of board, and it's actually really easy to cut it down to the size that you need. So you get this, you figure out what you need, and then you just scratch it with a knife a few times, then you can snap it quite easily. It's pretty flimsy material, so just make sure that you snap it first before you solder everything on, and then try to snap it, because sometimes you can break underneath with what you've built. These are good. I have some of these too. You can solder on both sides of these. These are a little bit more rigid, like you can't break these by hand. You can probably cut them if you wanted to, but you'd need a saw or something like that. So yeah, whatever you need. Those are the two different types. What I would say is also is about dry fitting. When you're building these things, I haven't had very much luck with unsoldering things, so I'll dry fit something like 20 times before I start to solder it, because once it's soldered, it's really hard to deal with, right? So, and in terms of soldering the header pins on, so if you're going to mount this Arduino on here, what I always do is solder it. Oh, one more. One more still. So if you use the proto board to align the pins, you always know it's going to be good. So sometimes if you're soldering them on a table or something, there's a chance the pins won't be exactly straight. If they're not exactly straight, you'll never get it in this board. So what I do is just fit it in, put something on two sides, and then just quickly solder two pins, like one there or something, and then take it out. Make sure it comes in and out easily, and that the pins are exactly straight up and down, or else you're not going to get them onto this board. Another thing, you don't need the headers if you want to work with a proto board. The other thing you can do, I've seen people do, you put the Arduino, or you put the wire in from underneath the side that you would solder, and then just thread it through a pin, if I can see it there. So then you don't need the headers. The thing that's keeping the Arduino in place will be the pin coming up from underneath. It's just all personal choice. Or, I mean, if you don't want to use the proto board, you can just solder the wire directly onto the Arduino itself. Or, if you don't want to use a Nano and you're more comfortable with the Arduino, just stick the pins in there. That's all you really need to do, and then just secure this so pins won't fall out, and you're good. All right, guys, that's it.